Hello, David Kenworthy here. It's 25th of the 5th, 2022, and we're looking at the solution to the problem posed in the previous video. And this video is titled The Giza Great Pyramid, Egyptian Route to Pi, a journey of ancient mathematical discovery, a solution for metrologist Melissa Campbell. And we're also looking at some of the work of Jim Wakefield in the solutions here. And Jim Wakefield sends his regards to you, Melissa. And the Egyptians discovered the approximation of pi that works with root 2. And it's root 2 times 20 over 9. And when you square this version of pi, you get 20 over 9 squared times 2. And 20 over 9 squared, as you can see in the calculation on the left-hand side, is 400 over 81 times 2. So you get 800 over 81. Now in decimal notation, this is 800 over 81, and we can see it here. 800 divided by 81. And Berriman tells us this in his book. He tells us exactly that the royal cubit in digits divided by 9 is pi. And that's what's happening here. This is exactly what he's telling us is happening. Now if we look at this times this, we get 4.444, which is 40 over 9. So pi times root 2 is giving us this number, 4.444, and we know when we divide that by 10 and multiply it by 9, the inscribed square when this is a circle is 4. So the side of the square is 1. There's no argument here, that's exactly what Berriman tells us. Now we want to reduce the size of this version of pi. And when we multiply it by 11, we get this number, 34.56. And when we divide that by 1.2, we get 28.8080. And we want to shave that number down to 28.8. And when we do that, this version of pi changes to Fibonacci pi. I've been told that Fibonacci pi does not exist. It's just pseudoscience. It's not genuine. It's spurious, or it's a sham. It's a sham calculation. Well, I got this calculation from Jim Wakefield. And he showed me that when the diameter is 1100, the circumference is 3456. And when I looked at that circumference, it's 12 times 12 times 12 times 2. So it's 12 cubed times 2. And this is what these people were doing. They were putting cubic units into straight line measure. And this 3.14181818 we also get off Harry Sivertson and also from John Neal and John Michel. Now we're getting it by using 28.8, and we can apply the simple Giza solution, time solution, to 28.8 inches and see what it produces. So we multiply by 864, we get 24883.2 seconds, where 864 seconds is 1 inch. And we all know as metrologists what John Neal and John Michel produced. And it's in John's book, Opus 2. And it's that number. And now we're going to look at the Egyptian megalithic yard, which was what the previous video is about. And when we multiply root 2 by root 3, we get root 6, which is 2.44948973. They used an approximation. They also use this. Now when we multiply that by 2, we divide it by 2 and multiply by 20 over 9, we get this number here. A20 times B20 divided by D20, which is 2, times 20 over 9, we get that. And that means that times 10 over 9 is the Egyptian megalithic yard. Now the Egyptian megalithic yard is meant to be squared. When we square it in feet, we get 7.407,407 recurring, and we multiply that by 6, we get this number here, multiplied by 10. So that is 400/9, automatically produced. When we change the megalithic yard into inches and square that, we get 1066.667. Multiply that by 6, we get 100 hecart. The whole calculation is hanging on this number here. If I change that to the megalithic inch, which is there, we get some extraordinary results appearing. So the Egyptian megalithic yard now becomes 6.666. We multiply that by 12, we get 80. We square that, we get 6400. And multiply by 6, we get 38400 divided by 2, 192 by 296. John Neal knows all about that number. And then we're going to go to the Aubrey Circle as a final visit. 897.6 feet, 2.448 as the square root of 6. Divide by that, we get 366.6667. Do I really need to say anything more? That's it for now. Thank you.